Section 5.2 covers the probability with tree diagrams. I like this section because it actually gets into one of the main concepts of stats, which is probability and chance and how things can happen, how certain events can occur. The essential question is, what is a tree diagram and how do you make one? And then we have a few definitions. Theoretical probability is using mathematical computations to calculate the probability. An event is an outcome or set of outcomes of a random phenomenon. A sample space is the set of all possible outcomes. For example, the sample space for flipping a coin will be written like this. S for sample space equals, we put brackets, could be heads or could be tails. So S equals heads or tails. The sample space is heads or tails. Okay, and an event would be like if you flip the coin and you end up with a head. So the event would be I just flipped a head. Okay, and a tree diagram is a diagram used to find the sample space for a combination. Zoom in a little bit. For a combination of independent events. So in many cases, there's many possible outcomes, and we're going to use a tree diagram to show that. So let's look at example 1. The sample space for a combination of flipping a coin and rolling a dice is as follows. Okay, so if we flip a coin, what are the possible outcomes you get when you flip the coin? You could get either heads or tails. When you roll the dice, a 6-sided dice, what are the possible outcomes? You could roll a 1, you could roll a 2, you could roll a 3, a 4, a 5, or a 6. So our possible outcomes are kind of drawn in this tree diagram. So basically, you flip the coin, you either get a head, let me go to highlighter. You either get heads or you get tails. Okay, that's one of your options, either a head or a tail. Okay, and then you roll the dice. If you roll the dice, let's say you flip a head, then you could roll a 1. You could also flip a head and roll a 2, a head and roll a 3. You'd flip a head and then roll a 4. You flip heads and roll a 5, or flip heads and roll a 6. Okay, so those are your possible ones when you flip a head. If you flip a tail, you could do tails and a 1, tails and roll a 2, tails, roll a 3, tails, then roll a 4, tails, roll a 5, and tails, roll a 6. Okay, so there's actually 12 possible combinations. And how we would write these out, we could put like H1 for heads and 1, H2 for heads and 2, H3, H4, H5, and H6 are all the possible heads. And then T1, T2, T3, T4, T5, and T6 are all your possible tails. So the sample space has 12 things in it, and those 12 things we just listed. There's 6 possible combinations when you flip a head, and there's 6 combinations when you roll a tail. So 12 total. Each outcome has an equally likely chance of being chosen at random. Right? When you flip that coin and you roll that dice, it's just as likely to flip a head and get a 6 as it is to flip a tail and get a 1. So what is the chance of getting it? Well, it's 1 out of the total number of possibilities. So there are 12 possibilities. So the chance of getting one specific combination, like heads and a 6, is 1 out of 12. Okay, the checkpoint says, what is the sample space for the number of heads in 4 tosses? Okay, so if we toss a coin 4 times, what are the possible outcomes we would get? you flip that coin 4 times in a row. 1, 2, 3, 4 times in a row. What are the least number of heads you could get? That would be 0. You could flip the coin 4 times and get all tails. You could get 1 head, you could flip 2 heads, or 3 heads, or 4 heads. Okay, those are your possible outcomes. 0, 1, 2, 3, or 4 heads when you flip it 4 times. All right, and then the probability of event is as follows. Probability of A, which is probability of anything happening, is the number of favorable outcomes divided by number of total outcomes. So favorable outcomes divided by total outcomes. Okay, favorable are the ones you're looking for. Like maybe you're looking for flipping a head. Maybe you're looking for rolling a 6. So those are the ones that are favorable, the ones you're looking for, and the total is the total amount. So in example 2, it says, use the example of flipping a coin and rolling a 6-sided dice. So these possible outcomes right here. It says, what is the probability of a head and rolling a 4? Okay, so if you look up here, how many heads with a 4 do we have? That would be 1. Right here is the only heads with a 4. So that'd be one possibility, the H4. So heads and rolling a 4 would be 1 out of 12. What is the probability of getting a tail and rolling a 3? So tails and a 3, there's only one of those where you get a tail and a 3. So that's, again, 1 out of 12. Because there's 1 tail and 3, and there's 12 total. The favorable outcome would be tails and a 3. The total outcome is 12 total, so it's 1 out of 12. How about C? The probability of getting a head and rolling a 4, or a tail and rolling a 3. So if you look at part A, the head and 4 was 1 out of 12. The tails and 3 from part B was also 1 out of 12. So if you put them together, the probability of getting heads and 4 and tails and 3 will be 2 out of 12. And this reduces down to 1 out of 6. So it'd be 1/6 chance that you get either heads in a 4 or tails in a 3. D, what is the probability of getting an even head? So an even number and flipping a head. So we look at the row of heads. Okay, the even numbers and a head would be like heads in a 2, heads in a 4, heads in a 6. So how many of them are there? There's 3. 2, 4, and 6 with the head. So it's 3 out of 12. And if you reduce 3 out of 12, you would get 1 out of 4. So the probability of that one is 1 out of 4. Go back and box those up. Part E. What is the probability of getting a head and a number greater than 2? Okay, I'm going to use a different color. Heads and number greater than 2. So heads in a 1 is not greater than 2. Heads in a 2 is not greater than 2. But heads in a 3, heads in a 4, heads in a 5, and heads in a 6. These four would all work. So that would be 4 possible favorable outcomes. One of those 4 would be favorable. So 4 out of 12. Four out of 12 will reduce down to 1/3. And then lastly, what is the probability of getting an even head or a head greater than 2? So an even head or a head greater than 2. Okay, let's go look at this. I'm going to use green now. Even heads would be like H2, H4, and H6. And a head greater than 2 would also include H5 and H3. So how many of those are circled in green? There's 1, 2, 3, 4, 5. 5 favorable outcomes that would be heads and even or heads and greater than 2. So this would be probability of even head or a head greater than 2 is 5 out of 12. Okay, and then our last two examples actually work on drawing the tree diagram. So example 3 says you have just graduated from college with your degree in actuarial science and have decided to buy a new Jaguar. The two models come in 3 exterior colors. They could be red, black, or blue. The leather interior is 2 colors. It could be tan or white. And you have a choice between a regular top, a soft top convertible, or a hard top convertible. Make a tree diagram of this situation and determine the theoretical probability of randomly choosing a red convertible with either color level. A red Jaguar convertible in either color leather. So let's start with the first thing they tell us. They tell us that 3 exterior colors, red, black, and blue. Okay, so we're going to start with the exterior color. Oops, there's no E in color. This would be red or black or blue. Those are the possibilities. Okay, then you'd have to choose what kind of leather. The leather interior comes in 2 colors. So this would be leather. Leather would either be tan or white. So you can get a red Jaguar with tan leather or a red Jaguar with white leather. You could get a black Jaguar with tan leather or a black Jaguar with white leather. And then you could do a blue Jaguar with tan or a blue Jaguar with white. So those are the possible combinations for the leather. So we have exterior color, and then you have leather. And then lastly, you have the top. Oops, again, I'm adding letters in here. Okay, this top can be a regular top, a soft convertible, or a hard convertible. Okay, so we would have regular, soft, or hard convertible. That could be the one with the tan. Okay, the one that's got white leather could also be regular, soft, or hard convertible. Same thing with the next one, regular, soft, or hard convertible. And regular, soft, or hard convertible. And then last one, the blue and tan one could have a regular, soft, or hard convertible. And the blue-white leather could be regular, soft, or hard convertible. So you see how they all kind of branch off, and there's many, many possibilities. Okay, so I'm just going to grab my highlighter. So let's say that you chose that you wanted a black Jaguar with white interior leather and a hard convertible top. Okay, you would have the green lines there. You could also choose a black Jaguar with tan leather and a soft convertible top. So you see, those are just 2 of the options. Those are the possible options we're looking for. We're trying to see what we want. So they told us Let me actually undo what I just did. So go back. So they told us that we want to look for a Jaguar that's red and a convertible in either color leather. So let's highlight that. Red with either color leather. So it could be red with tan leather or red with white. And then it's got to be a convertible. So it could be red and tan with a soft convertible top. It could be red, tan with a hard convertible top. It could be red, white leather with a soft convertible top, and red, white leather with a hard convertible top. So the possible ones are right here. There's 4 possible outcomes, 4 favorable outcomes. Okay, the 4 favorable outcomes are circled. And how many are there total? There's 18 total outcomes. So 4 out of 18 would be 2 out of 9. So what is the probability if you randomly chose that you choose one that's red with either color leather and has a convertible top? It would be 2 out of 9. Okay, and the last one, it says create a table of sample space for flipping 4 two-sided coins. What is the probability of getting exactly 2 heads? Okay, so we could flip it and we could get 0 heads. It could be tails, 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 tails. We could flip the coin 4 times and we get 1 head. It could be heads, tails, tails, tails. It could be tails, heads, tails, 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 heads, tails. It could be tails, 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 heads. That's the possible way to get 1 head when you flip it 4 times. What if we get 2 heads? Okay, this list gets longer. We could go heads, then a tail, then a tail. It could also be heads, then tails, then heads, then tails. It could be heads, tails, tails, heads. Now it could be tails, heads, heads, tails. It could be tails, heads, tails, heads. And it could be tails, tails, heads, heads. What if we got 3 heads? 3 heads could be heads, then heads, then heads, then tails. You could flip heads, then tails, then heads. Heads, then tails, then heads, then heads. And tails, heads, heads, heads. Those are the outcomes for when you got 3 heads. And what happens if you get 4 heads? It would just be heads, 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 heads. Okay, so let's count. How many total outcomes are there? There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 7, 8, 9, 10, 11. 13, 14, 15, 16, 17. So I count 16 total. So there are 16 total. And how many are there when you get 2 heads? There is 1, 2, 3, 4, 5, 6. So 6 out of 16 total is 3 out of 8. So what is the probability if you flip a coin 4 times in a row that you would get 2 heads? It's 6 out of 16, which is 3 out of 8. All right, and that's what we're going to cover with probability and tree diagrams. I will see you all in class.